Karl Fischer Moisture Titrator MKV-710. Karl Fischer titration is a widely used method for measuring the water content of various substances. This method is known for its reliability and is used to make analytical measurements by many official methods of analysis such as ASTM, UOP, JIS, and Japanese Pharmacopoeia, and so on. With the ability to connect up to 4 measuring components, multiple measurements can be made simultaneously in parallel, which also allows for saving space. Not only MKV-710B volumetric titrators and the MKC-710B coulometric Karl Fischer titrators, but the AT-710B automatic potentiometric titrators can also be connected. The volumetric titration method. The volumetric Karl Fischer titration method measures moisture content by reacting iodine and sulfur dioxide quantitatively in the presence of alcohol and a base. Moisture content measurement by the volumetric titration method involves placing a solvent into a reagent bottle and adding to it a Karl Fischer reagent via titration until it reaches an anhydrous state. The moisture content is measured using a previously determined factor, a measured amount of Karl Fischer reagent, and a water standard methanol solution. The titration is carried out by controlling the titration speed with a sensor electrode that checks the polarization potential voltage, while the titration speed is controlled mechanically. About the Karl Fischer Moisture Titrator MKV-710. Unpacking and checking of standard parts. The contents of the package include the MKV-710 main unit, accessories, operation manual, etc. Please confirm that everything is present while referencing the list. MKV-710M main unit. Magnetic stirrer, automatic solvent change unit included. Stirrer cable, AC adapter, power cord, EBU 710KF, buret unit. Operation manual for dot matrix printer, IDP 100. MKV-710 operation manual, CD-ROM. MKV-710 quick manual. Contact. Inspection certificate, warranty. The Karl Fischer reagent KEM AQUA series is a reagent dedicated to the Karl Fischer Moisture Titrator manufactured by Kyoto Electronics Manufacturing Company Limited. Part names and functions. We will explain the names and functions of the various parts of the MKV-710. Buret number 1. This can be used by setting the buret number parameter to 1. Detection electrode connector. Connect the twin platinum electrode. Stir port. Connect the stirrer cable to the main unit. USB connector. Connect it to the MCU 710. COM1 and COM2 ports. You can connect a dot matrix printer to COM1. The evaporator can be connected to COM2. SS bus connector. A connector for options such as additional buret. Stir connector. Connect a magnetic stirrer here to stir the sample solution. Power connector. In, out. A connector for the power cable. Installation and preparation for power on. Slide the buret unit in from the right and hook the piston rod of the buret unit to the drive screw of the main unit. Attach the buret unit to the guide pins in both places of the main unit while inserting the buret unit into the housing holes. Slide the housing on the guide pin of the main unit to make it easier to adjust the vertical position. Tighten the buret stopper and secure the buret unit. Assembling the titration cell. Attach the titration vessel top to the magnetic stirrer with the screw. Widen the fixing lever of the titration vessel top out and fix the titration vessel with the stirrer rotor inserted. Lightly apply KF grease to each part. Attach the detection electrode, the desiccant tube for the titration vessel, and the port plug to the titration vessel top. Adjust the mounting position to the specified position. Insert the plug of the cord of the detection electrode into the connector and screw the plug in securely. Assembling the buret unit. Thread the connection tube through the reagent bottle cap and tighten the fitting. Tighten the connecting tube to the number 2 position of the switching valve. Attach the nozzle cover to the bottle stand. Tighten the diffusion-proof nozzle to the tip of the opposite side and attach it to the titration cell unit. Place the diffusion-proof nozzle with its discharge outlet facing outside. When titration nozzles are used with quantitative injection, change the diffusion-proof nozzle to the nozzle FEP before connecting it with the tube. Remove the seal from the desiccant tube. Put the desiccant tube in the reagent bottle cap. Place the bottle in the bottle stand. If the outer diameter of the reagent bottle does not match that of the bottle stand, use the bottle holder. Thread the connection tube through the reagent bottle cap and tighten the fitting. Align the tube to a position that reaches the bottom of the reagent bottle. Assembling the automatic solvent change unit. Put the bottle for dehydrated solvent and the waste bottle to the solvent bottle cap and waste bottle cap respectively. Drain tube in. Connect the drain tube to the peristaltic pump on the back of the magnetic stirrer. Plug the titration vessel plug into the predetermined position of the titration cell unit so that the tube does not break. Drain tube out. Connect the drain tube and the injection tube to the solvent and waste bottle caps respectively. Put the silicone tube to both sides of the desiccant tube and attach the desiccant tube to the reagent bottle holder. Connect the connected silicone tube to the solvent connector on the back of the magnetic stirrer. Place the bottle in the bottle stand. If the outer diameter of the reagent bottle does not match that of the bottle stand, use the bottle holder. Connect the silicone tube to the bottle cap. Connection of cables. Make sure that the power switch is turned off. Connect the AC plug cord to the AC adapter and connect the other side of connector plug of the AC adapter to the power connector on the back of the main unit. Connect the stirrer cable to the stirrer and the main unit. Printer connection. You can print titration results and parameters by connecting a printer. Set the paper. When paper is cut on an angle, it is easier to insert. Turn on the power switch. Titrant filling. A concentration difference occurs between the reagent in the buret and the reagent in the reagent bottle. To remove this concentration difference, perform a purge. Press Option button. Confirm that the buret number is set to number 1. Purge times 10. Purge mode to bottle. Press up or down button and the piston head will move up and down, filling the buret with reagent. Next, fill the nozzle with the reagent. Press up button. Press up button and inject the reagent. Press up button to stop injection of the reagent. Settings preparation. First, we will carry out a pre-titration to dehydrate the titration cell. A wait for pre-titer will be displayed. Press the pre-titer button. A preliminary titration is started. Factor measurement of reagent. This time, determine the factor of reagent with water standard 10. Press the method button and select option number 4 factor STD material. Press the OK button to return to the home screen. Make sure that 004 factor STD material is displayed at the top of the home screen. Press the sample button. Press the constant button. The standard substance concentration is displayed as 100% against water. For a factor measurement of water standard 10, enter the standard substance concentration to 1.0%. Press the home button to return to the home screen. The message "Drift" is displayed on the screen. Press the Start button once. The message "Preparing for titer" appears on the screen. Inject sample and please press Start button will be displayed. Insert the water standard into the titration cell. Press the sample button and enter the total weight into WT1. Press the bat button once. Remove a silicone rubber from the syringe and open a port plug on the titration cell unit. Close the port plug of the titration cell, press the Start button, and start the measurement. Measure the weight of the syringe, press the sample button, and then press WT2 button. This time, we will enter 70.5535 grams. This is the amount after the sample was injected. Press the Home button to return to the home screen. After the measurement is completed, the measurement results are displayed. This is a series of measurements. Sample measurement. Entering sample measurements. Press the Method button. Select number 1 normal titration to change the method from factor measurement to sample measurement. Press the OK button to return to the home screen. Confirm that the number 1 normal titration is displayed at the top of the home screen. The message "Drift" is displayed on the screen. Press the Start button once. The message "Preparing for titration" appears on the screen. Inject sample, and please press Start button will be displayed. Remove a silicone rubber from the syringe and open a port plug on the titration cell unit. Use the unit markers as a guide to put 1 milliliter into the titration flask with the reagent. The measurement will start. Press the sample button and enter the total weight into WT1. Measure the weight of the syringe. Press WT2 and enter the weight. button to return to the home screen. After the measurement is completed, the measurement results are displayed. Options. Various options are available for the Karl Fischer Moisture Titrator MKV-710. Evaporator ADP-611. Evaporator for oil samples ADP-513 non-CE. Heat extractor for sugar samples ADP-344 non-CE. Evaporator for ores ADP-512 non-CE. Evaporator for high temperature ADP-512S non-CE. This time we will briefly introduce the evaporator ADP-611. The evaporator allows to measure the moisture content in powders or solid samples that cause side reactions and therefore cannot be titrated directly. Heat the sample and bubble the evaporated water vapor with carrier gas into the cell for measurement. Press the Method button. Select Number 7 Evaporation and press the OK button. Press the preliminary measurement key and start the preliminary measurement. We will use a finger-shaped sampler this time. Place the finger-shaped sampler on the electrical balance and place the sample on the sampler. Put the sample boat in the evaporator and press the Start button. The measurement will start. Press WT2 and enter the weight. Enter the weight into WT1. Enter the weight of the sample left in the finger-shaped sampler. After the measurement is completed, the results are displayed. This is the series of procedures for the measurement with the evaporator. In addition to the finger-shaped sampler used here, various other shapes of samplers have been prepared depending on the type of measurement. Kyoto Electronics manufacturing brand Karl Fischer reagent. Karl Fischer reagent KEM AQUA is a reagent dedicated for use with the Karl Fischer Moisture Titrator manufactured by Kyoto Electronics Manufacturing Company Limited. But these reagents can also be used for all commercially available Karl Fischer Moisture Titrators on the market. Our lineup can be available for various samples. Standard materials, water standard, solid standard are also available. Karl Fischer Moisture Titrator MKV-710. Measurement of moisture content by the Karl Fischer method has been adopted by many official associations such as ASTM, UOP, JIS, and Japan Pharmacopoeia, and so on. As it gives the most reliable moisture content reading, it is widely used for the measurement of the moisture content of various substances. Not only MKV-710B volumetric titrators, and the MKC-710B coulometric Karl Fischer titrators, but the AT-710B automatic potentiometric titrator can also be connected. Multiple measurements can be made simultaneously in parallel, which also allows for saving space.